Hello and welcome to video 5 in this video series. What we did in the last video was to create this code that I'm showing you on screen now, and what this code did was it animated a bird walking across the screen. Now we had some problems with this code which were highlighted in the video, and those problems primarily was that this code would block your microcontroller, so your microcontroller couldn't do anything while it was playing the animation, and also we would struggle to play multiple animations because we would start to run out of memory because we're passing the icon to the function for each animation. So what we're going to do to get past these issues is to embrace something called object orientated programming, and we're going to use OOP principles and create a class. So we'll create an animation class, and all that class will do will track the X coordinates, the Y coordinates and the current frame that we need to display in our animation. And by doing this we will be able to have multiple animations on the screen at the same time without having the issues with memory issues with the icon, and without having the write issues as well. So if you remember from the last tutorial, the send buffer function for the screen takes about 35 milliseconds to execute, and if we were to have multiple animations using this function, it will take 35 milliseconds to write each animation to the screen, whereas with our object orientated method using a class, it will take the same amount of time to write the object to the screen regardless of how many objects we have. So this video is a little bit different. I'm not doing a code along for this video. I've already written the code and I'm just going to go through it with you. So this is the code that I've written, and all of this code can be downloaded from either leap.uk/UHE2 or from our GitHub page. All the links for these videos are underneath this video if you need to access them. So this is the class that I've created. So this is a class that I've created that gives us the same functionality than what we had before, but it does it in a better object orientated way. Now, as you can see on this code, I have two tabs. So we've got the first tab, which is your main tab, and this tab has the include statement to get the UHE2 library in. It has the creation of the UHE2 object called auxiliary screen. Then it has your icons. So in this tutorial we've got three icons. So this is icon 1 and all the frames. This is icon 2 and all the frames. And this is icon 3 and the one frame that we have for icon 3. Then we initialize the auxiliary screen object. We set the bitmap mode to 1, so that means that the bitmaps will be transparent, so when they overlap they look a little bit better when they overlap. We also initialize a serial port and we print AnyClass started, just so we know that our microcontroller hasn't crashed and it's working. Now in this loop, in our loop function here, I'm just going to ignore that for now and we're going to move straight into the class. So I created a second tab, and the second tab is called _00_GPX_class_latest. Right, the reason why I've put _00 there is to ensure that this tab comes after the GPX tab, because if this tab was before the GPX tab it wouldn't work properly because of the way that Arduino IDE compiles our code. So I've done that, and the first thing that we need to do when we create a class is to create what we'd call the header for the class, and this that I've highlighted here is the header for our class. And what the header for our class does is it tells the computer what functions we're going to have in our class and what variables we're going to have in our class. So for instance these here, so let's have a look. So all of this stuff here, these are all functions within our class. So we've got check animation, to increment, get X position, get Y position, get current frame, get width and get height. They are all functions within our class which we call public. They are public, and that means that we can access those functions outside of the class. And they're the functions we're going to be using for our animation. Now we also have this thing here that says animation, int width, int height, int frame delay, int x increment, int y increment, int x start position, int end x position, int start y position, int end y position and int frames. So this is our constructor for our animation class. So whenever we create an instance of our animation class, we need to call this constructor, and all this constructor is the width of our icon, the height of our icon, how much time to have between updating to the next frame, how much to move the animation on the x-axis per increment, how much to move the animation on the y-axis per increment, the starting x position, the end x position, the start y position, the end y position, and how many frames we have in our animation. So they're all the arguments that we're going to give to the animation class when we create an instance of it. Once they're given to the class will then create the object and display the animation as we want it to be displayed. So in the header file we also dimension, we also declare our private things as well. So under private we've got various stuff. We've got all of these, and these are all different variables that we're going to be using within our class. So we've got frame delay, x increment, y increment, x position, and y position, both start and end, frames, bar end x, bar end y, we'll talk about them later on, then current x, current y, current frame, width and height. We also got timer start. Then underneath all of them, and we'll talk about all of these when we talk about the code, then underneath all of them we've got a boolean move any. Boolean move any is a function which returns a boolean value, so a true or false value, and that decides whether or not the animation should move. So that's that. So that's our header for our class. And then underneath the header for our class, we'll have the actual code for our class, which is the rest of the stuff on this tab. So you must remember that when you write the header for your class, that you use the syntax that I've used here. So public and private, and then after them you have a colon. Then you put your code in as you normally would do, your functions and your variables that you want to be private and public, and then it's all closed off with a curly bracket and a semicolon. You must remember to put that semicolon in or your code will not compile. So when we write the code for our class, the first thing that we do is to create our animation. And you might have noticed here that our syntax is a little bit different now. So for everything that's part of our class, it has to start with the name of our class, which in this case is animation, and then 2 colons, then the name of the function. So for instance, this function is called chkIncrement. So it's animation. So this function doesn't return a value. So it's void because it doesn't return a value, and then animation because that's the name of the class, colon, then chkIncrement because that's the name of the function within the class. You know, I'll use the word function and I'll use the word methods. When I use those words, they mean the same thing. It's just that they're interchangeable. So yes. So the first thing we have is the constructor for our animation. Whenever this constructor is called, it will create an instance of our animation class. And we pass the constructor all of these values in the exact same way that when we used the function, the play animation function, we had the same values there, and they're used in the same way here. The only difference is in our play animation function we had size, bytes and icon, which we don't need for our class. So they're all passed to the class, and we pretty much take these arguments here that we pass within the constructor when we create an instance of the class, and we then apply them to private variables within the class. So all of these variables here are taking their values from what we have in the constructor arguments up here, and because we're giving them all values here, they will now be available for the rest of the class to use, for all the methods within the class to then use. And then we also give current frame of value, start x, start y position, which is from up here. Sorry, the current x and current y position, which is your start x and start y position, which is that value and that value, but they get their values from up here as well, don't they? And then we bar end y and bar end x values, which are true. So the bar end x and bar end y values will tell us when to stop the animation. So when the animation needs to be stopped, they will equals false. So they are the end x and end y boolean variables to tell us to come out of the loop and to stop drawing the frames onto the screen, or to re-loop or whatever, you know, to reset the loop, pretty much to reset the the current X and current Y position. That's what we're going to do. So whenever bar end X or bar end Y, well no, in order, both of them need to be equals to false. So whenever bar end X and bar end Y are equals to false, we'll then change current position X and current position Y to the start positions, and that's why we're using these. That's why they're called bar end, because it's inverse logic. You know, if it was equals true, which would mean end, then it'd be called end X, but because it equals false equals end, is bar end. And I hope that makes sense. The next function within our class is this one here, and this is called chkIncrement. And as it says there, it says execute every loop iteration and decides if we need to increment to the next frame. And all we're doing here is we're saying, do we need to move the animation? So this to move thing is something different, but here we're saying if we need to increment the animation, then just add one to the frame. If current frames goes beyond how many frames we have, current frame will equal 0. So let's say we've got a 4-frame animation, we're going to go from frame 0 to 3 and then back to 0. So frame 0, 1, 2, 3, then when we get to frame 4, because frame 4 doesn't exist, we'll go back to frame 0, and that's all that's doing. It's cycling our frames, and then this here is adding 1 to the current frame every time we decide to increment. This bit here to move, so as you may have noticed, when we have the chkIncrement function, we have a boolean to move value, which is boolean value, and that is so we can decide whether or not to move our animation. So for instance, every time we call the chkIncrement function, if you want to move your animation, you call that and then you put a true value in there. If you don't want it to move, you check that and you call a false value there. And by moving, I mean moving across the screen. So you can, by calling a false value there, have an animation that is stationary on screen but still being animated. And that's what we're doing there, pretty much. So let's have a look at move ani and to increment, these two functions. So to increment, and all we're doing here with the to increments function is we're saying if the current time minus when we started the timer is greater than our frame delay, then return true, or if it's not, then return false. So if our frame delay is 200 milliseconds and this is being called every 20 milliseconds, this would need to be called 10 times before it returns true. And a timer start is given a value right up here. So the timer start is given its value. I can't see what it's given its value, to be honest. So timer start is given its value. So yeah, so timer start, when it's initialized here, it's given a value 0. And then every time that this evaluates to true, we then give the timer start a new value, which is the current runtime in milliseconds, and then we return true. So this pretty much allows the animation to be incremented, not every loop iteration, because that'll be every 1 millisecond, which would be far too fast. Incremented whenever we decide to increment it. So for the animations that I use, it'd be every 200 or 150 milliseconds, because that's what I need to make the animations look natural and look as they should look, and that's what that's pretty much doing. And then we've got this function here, which is called move ani. Now move ani stands for move animation, and that is what we're doing. So it says here, looks at the x and y coordinates and evaluates if they have been exceeded. So what we're doing here, we're pretty much saying right, so we're looking at the x coordinates first. So we look at the x coordinates and then we look at the y coordinates, and we're pretty much saying here, do we need to move left or do we need to move right? So for instance, with your arguments for your animation class, you have your x start and your x end position. So if your x start position is less than your x end position, we know that you want to move from left to right. If your x end is greater than your x start, you're moving from right to left, and that's pretty much what these if statements are looking for. So they're pretty much saying, do we need to either add the increments to the current X position, or do we need to take away the increment from the current X position? That's what we're doing there. And so it will do that, and then it'll do some other stuff. It'll return the value because we return Boolean. That's just to say that this function has executed successfully. That's not really used now, but if we were to expand this class later on, we would need to use that, perhaps. And also, we're also giving bar end x a value. So in this case, we've evaluated the fact that we need to we're moving from right to left, so we need to minus from the x increment from our current position. We've done it successfully, so we're going to have a return value of true, and we've not exceeded the end x position. So here it says current x position. If current x position is greater than or equal to end x position, so we always, because we're moving from right to left, we always want the current x position to be greater than the end x position. As long as that's true, then we return these values, or given those values. However, if we exceed the end x position, so we go beyond the end x position, we want to return false to say that we've exceeded the end x position, and bar end x will also be equals to false, which will say that we've met our x position target, so we don't want to increment the x position anymore. And then for this one, exactly the same, but instead of moving from right to left, we're moving from left to right, so we want to add to the x increment to the current position instead of taking it away, and then we have these values here as well. So bar end x will be equals to false if the current position is less than the end x position, for instance, because we would have exceeded the target, the x target. And then for your y positions, the y coordinates work in exactly the same way. So are we moving from top to bottom? If we are, we need to take the y increment away from the y position, and otherwise we're moving from bottom to top, which means that we need to add the y increment to the y position. And then we've got this end bar y statement as well to say whether or not we've met the y axis target. And because this is in its own if statement and this is in its own if statement, and we don't return the return val, which is this, we don't return this until the end of the function, we know that the y coordinates and the x coordinates are independent of one another. So if we meet the end x position before we meet the end y position, we're still going to increment the y position until we meet the end y position. Then when we meet the end y position, this statement will evaluate true. So if bar end y equals false and bar end x equals false, we set our position, our current position, to the start position. So we loop not only the animation, but we loop the movements within the animation, if that makes sense. So if it's a bird running across the screen, we're going to loop between the frames all the time, but then when it gets to the end of the screen, it will then go back to the start of the screen, and that's what we're doing here with these bar end y and bar end x statements, and what this if statement's doing. And then to finish it off, we've got these helper methods. So we've got get x position, get y position, get current frame, get width, and get height, and all they're doing is returning these variables. So current x position, current y position, current frame, get width, the width variable and the height variable, and we're going to use them when we draw the icons on the screen. So that is the class. That's all the class is doing. It's just making a record of and incrementing the x and y coordinates and incrementing the frame for us, and that's all we're doing there. And then what we're going to do down here is actually create the objects. So down here we're going to create the objects, and here we've got 3 objects that we're creating, and then we're going to increment the objects. So the reason why I've done it this way, so normally this code that I've got here would normally just go in your loop method here. However, in Arduino IDE, if I was to put this code in the loop method here, I'd get errors, and the errors would be that they can't find this animation class, because the animation class is after the code trying to use it, and because Arduino IDE works in an interpreted rather than a compiled way, it would give us errors. So what I've done is I've created an increment bird animation function at the end of the class and put all the code there in order not to get errors. Now when we turn this into a library and we start using a library, we'll do this differently, but for now this is how we're doing it. Okay, so we have this increment bird animation function, which is this function here, and we're going to call that every loop iteration. But before we call that, we're going to create the object. So we're creating an object called bird, an object called bird1, and an object called ground. Now bird is the bird running across the screen, bird1 is a dragon that's flying, and ground is the ground. And all we need to do, because we've now got a class, all we need to do to animate these independently of one another is to create them there by using their constructors, and then for each one we'll do, for instance, birds.chkIncrement open brackets true close brackets. So that's checking the animation to see if we need to increment it, and then once we've checked the animation we just need to draw it onto screen. So as you can see here, draw xbm, and then all these functions here. So these are functions within the class that we create. So bird, so the x position will be bird.get x position, the y position will be bird.get y position, the width will be bird.get width, the height will be bird.get height, and then the icon is just the icon that we declared here. So it's this icon here. So we're not actually using the icon in the class, but we're still using it here to draw onto the screen. And because we're doing this, so these draw xbm functions, they take no time at all to execute, but it's this send buffer function that takes all the time to execute. Because we're only calling this send buffer function once, this to draw these three things onto the screen, it's only going to take 35 milliseconds because we're calling send buffer function once rather than for each object as we were doing in the previous tutorial. And because these are objects that are all being incremented every loop iteration, and because we've got this frame delay function here, and this check animation function here, that these will be drawn to the screen independently of one another, which is great, which is a great feature. So for instance, frame delay here for the bird running across the screen, every 200 milliseconds will go to the next frame. For the dragon, every 150 milliseconds will go to the next frame. We've got an x increment here, so the bird will have an x increment of 2, so for every increment it will move 2 pixels, whereas the dragon, which is called bird1 here but is a dragon, will move 6 pixels every increment. So not only will it'll be 3 times quicker than the bird. And then we've got the x start positions, the x end positions, the y start, the y end, so they're not going to move on the y axis. They're going to run across the screen on the x-axis. On the y-axis, I don't know why that's set to -8, that should be set to 15. They're not going to move on the y-axis either. And yeah, this is what the animation looks like as I showed you at the start of the video. So you've got 3 sprites independently being animated from one another. You've got the bird running slowly across the screen, the dragon running flying fastly across the screen, and the ground that's not moving at all. And you can see how all of that is achieved through this little bit of code here. Now feel free to go to the website and download the code, experiment with the code, change the code. This code is as basic and simple as I can get it for this tutorial. It has its uses, but if you were to want to draw animations on the screen, you might want some more functionality, which I'll add to the library when I create the library, but for now that functionality isn't added. So if you need more functionality, go to the GitHub page and download the library, and the functionality will be there. There won't be a video explaining the functionality, but there will be examples within the library explaining the functionality, which will allow you to interact with the animation rather than just having an animation play. You'll be able to interact with the animation, so you'll be able to move left for instance, and the animation will move left, or move right and the animation will move right. And once we have that functionality built into our class, we can then use that as a basis to perhaps create a simple game. So once we can react to user input in a non-blocking way, we can then create bounds for the objects, and then you've got a basis for a simple game that could run on Arduino, for instance. But that's it for now. So this is a simple, hopefully that was quite quick and quite painless. The next tutorial will be taking this code here that we have in Arduino IDE and exporting it into a class. So we'll create a class and then we'll import the class into Arduino IDE, and then we'll use it. We'll use that class in tutorial number 7. Tutorial number 7 will be super quick, where we're just using the class, and I'll show you why, or the benefits of using a library rather than having the class written in Arduino IDE like this. So I hope to see you at the next tutorial. Thank you for listening, and I hope you got something out of this. Goodbye for now.